So last time we talked about vectors. We spent a huge amount of time on vectors. So hopefully that was just to get the ideas in your head. When you do the problems, you'll become an expert with vectors. We talked about the notation, and I told you the secret that what you're really struggling with in vectors is transferring between two coordinate systems, polar and Cartesian, polar bear and rainy day Cartesian. And we talked a little bit about how to add and subtract and multiply by a constant, and maybe the adding gave you some insight into why we use the unit vectors. Remember the unit vectors? So hopefully that all helped. And we'll do a lot more today of identifying them in kinematics problems, because as you know, we moved on to kinematics. Okay? So we're describing how things move in 2 dimensions now. You throw something up in the air, and it's accelerating down due to gravity the whole time, but it may be moving this way. And for now, those 2 things are separate. So the one problem that we worked on last time in detail was the shoot and the drop. Remember, we did shoot and drop. One thing shot this way, one just dropped this way, and they took the same time to get to the bottom. So I derived it and did my standard thing, and we found it takes the square root of 2h over g to get there. And then somebody asked a very good question at the end that illustrates what you have to do in a problem, the hard part of a problem. Remember, is all context, right? Somebody asked, well, why did you know to deal with the y? Remember that we had the y equation and we had the x equations. And what do we focus on the y and not the x? So the answer is you have to look at the problem. What were you asked? Right? That's the question. What were you asked in shoot and drop? One is going to fall this way. One is going to go like that. And the question was, will they hit at the same time? So which direction is going to determine if they hit at the same time? So hit meant hit the ground. They're up high and they go low. So it's got to be, the question is leading you to think about the y. If the question had been, how far does this one go in the time it takes this one to hit the ground? Then how far, you would think, oh, that means the x. Right? But the question was only about how long does it take to drop. Right? Drop means down. So you draw it and you say, they mean down. In a Cartesian coordinate system, that's what we've been calling the y. So that's how I knew. It's from reading the problem and getting context. They will often, a problem will not say, calculate the velocity in the y after t.2 seconds. We know you can do that. You just plug it into the formula. So the problems have these kind of questions that rely on a little bit of context. So think of them that way. Okay, so let's see. The first thing then we're going to do is, so we're going to consider shoot and drop done and solved. And that was basically an example of sort of doing this, but we didn't really call it a projectile.